A travel agency offers a group rate of $600 per person for the weekend in Lake Tahoe if 20 people sign up. For each additional person who signs up, the price for all participants is reduced by $10 per person. So each additional person makes price reduced by $10. In other words, if I have, so I start with, let's look at it like this. We have the cost per person, and then we'll have the number of people, just to get an idea of what this statement means. The cost per person is $600 if 20 people sign up. If, let's say, you have one more person sign up, the cost is going to go down by $10. If you have two more people sign up, the cost is going to go down by another $10. In other words, 600 minus 2 of those $10 that they sign up for. If you have 3 more people sign up, the cost is going to go down by 110, another 10, and another 10. So that's really 600 minus 3 of those $10 bills that the cost goes down by. So if I follow this pattern, if I have part A says, write an algebraic expression for the size of the group and the price per person if X additional people sign up. So not one additional, not two additional, but not 3 additional, but X additional people. So that's 20 plus X for the number of people in this column. And in this column, what is the cost? It's really 600 minus the X people that cause $10 reduction. So remember, 3 tens, 2 tens, 1 10 for each additional person, or 2 additional people, or 3 additional people. For X additional people, X multiples of 10. So 600 minus 10X, let's say. So what's important here for us is that this is an expression for the cost per person, and this is the number of people that sign up if some variable amount of people sign up. So part A says, what's the size of the group? That would be 20 plus X. What is the price per person? That would be 600 minus 10X. So you keep reducing $10 for the X people that sign up. Part B says, write a formula for the travel agency's total income as a function of X. So total income as a function of X basically means revenue, which is the price per item times the number of those items. So price or cost per item or per person is right here, 600 minus 10X times the number of people that sign up, and that's 20 plus X people that sign up. And notice it's in function notation R of X. So the formula is basically the size of the group times the price per person, and that's the income that the travel agency generates. What is the maximum income the travel agency can earn on the Lake Tahoe weekend? So whenever they ask for maximum, we're basically thinking, hey, this must be some parabola opening downwards that's causing a maximum. Is that the case or not? Let's go and actually multiply this out. So when I multiply this out for part C to see what these two binomials look like, I multiply it out or FOIL it out, whatever you want to call it, and I combine like terms and I put it in descending order, and yes, indeed, it looks like it's going to be a downwards opening parabola that's going to cause it to have a maximum. And so I have to pay attention to what the parabola details. This will be X and this will be R of X. And if they want the maximum income is basically the revenue they want. So I have to find the Y coordinate of the vertex. So first I find the X coordinate of the vertex, which is negative b over 2a. That gives me 20. Now I got to go plug that back in here or in here, whichever version you want, to get the Y coordinate, which will give me the maximum revenue. So once we plug in the x coordinate back into the revenue function, I chose to plug it in here in the factored version. If you plugged it in here, you would get the exact same answer. Once I plugged it in, I got 16,000. So I got the vertex to be 20, comma, 16,000. In other words, this is 20. And this is a rough sketch, of course, not the actual graph. So there's the vertex coordinates, and 20 stands for the x, 16,000 stands for the r of x, and remember x stands for the, let's go back, additional people that are needed to sign up, and r of x stands for the revenue. So what is the maximum income or revenue? It looks like it is $16,000. How many people should they enroll to achieve this income? How many people should they enroll? Well, they already had 20 to begin with. They need another 20 additional people. So for part D, they already had 20 people, because that's what the original problem said. There were 20 people that had already signed up. They need X more, which we found to be 20. So 40 people total is what they need to achieve this maximum revenue. How many people should they enroll? So pay attention to the words, because if it said how many additional people should there be, I would just say 20, because 20 stands for the additional people needed. But I assume when they say how many people should they enroll, that means the total people, which would be the 20 plus the 20, which is 40 people in total. How many people must sign up in order for the agency to bring in at least this much in revenue? So at least that much in revenue means, or in income means, I have to go plug that in here in my r of x function, and I'll put it in the quadratic form since it's already multiplied out, and then I can see how I can solve that. So again, 40 people, we said that's part of C. Part D says how many people must sign up in order for the agency to bring in at least this much. So in other words, if I'm thinking of it graphically, at least 15,750, let's say it happened right there, would require me to have that portion be highlighted, because that's the amount that's above 15,750. So I would need to find what that x coordinate is and what that x coordinate is, because in that interval I would be able to achieve a revenue or an income that's above the 15,750. So graphically that's what's happening. Algebraically, I'm going to take this guy and go put it inside the revenue function as I have here for part D. I put it in for r of x. I got my 0 on one side because it's a quadratic equation. Then I notice that everything is divisible by 10 and make it a negative 10 because I like my leading coefficient to be positive. Once I do that, the quadratic equation becomes a little bit more simple, and I can go ahead and start either factoring this or use the quadratic formula if it is factorable. And it looks like it is factorable. 15 times 25 gives me 375, and both negative add to negative 40. So x is either equal to 15 or x is either equal to 25. So the two x values graphically that I'm obtaining are either 15 or 25, equidistant, happening from the middle, which was the vertex. So that makes sense because it's a symmetric graph. So I need 25 more people to sign up, or I need 15 more people to sign up. And we already had 20 people to begin with. So 20 plus 15, 35, and 20 plus 25, I guess, 45. So we need between 35 to 45 people to have the 15,750, was it? Yeah, 15,750 income. And if we wanted an interval notation, we can say from 35 all the way to 45, or I guess you can have it open interval, but I would rather say maybe closed, because at exactly 35 you achieve that, at exactly 45 you achieve that again, and anything in between gives you that revenue that's higher, the revenue that's higher than that amount. And since it says how many people must sign up to bring at least that much, then this 35 people would be sufficient and 45 people would be sufficient, and the number in between as well.